It should be no surprise to learn that here at Modus, a lot of us love video games. I mean, come on. Whether it was the inserting of cartridges in consoles, I don't know if that's audible, but my cat's using the litter box. It should be no surprise to learn that at Modus, a lot of us really love video games. I mean, come on. Seriously though, when it came to development of Modite Adventure, we wanted to develop something that was memorable, difficult, and absolutely a blast to play. I recently created a video that described how we created the music for the video game and talked through some of the decisions and workflows that we used. Today, I'm going to walk you through the graphic side of the game. Let's begin. Instead of developing sprites from scratch, we decided to speed things up by purchasing assets on itch.io. We selected a few different graphics packs and essentially mashed them up together to create this experience. We began by looking at the Wonderdot RPG series. This series contained the hero as well as the many monsters we see in the game. However, the backgrounds weren't very diverse, so instead of having to create backgrounds from scratch, we elected to go a little further. And for that, we used the Time Fantasy Asset Pack. This allowed us to have a diverse set of backgrounds in addition to a wealth of characters that we use for monsters as well as bosses. You see, while the LDK game console is capable of displaying thousands of colors, our game engine is limited to 256 colors. We did so for a few reasons. 1, less colors means less memory to process. 2, less colors means less CPU time to process those colors in. And 3, it allowed us to emulate the old school consoles that we loved. So it gave us some artificial constraints that I believed helped us develop an awesome game. Okay, let's take a look at our hero. Our hero character essentially is a bitmap containing all of the sprites for the character. The first thing you'll notice is that the character sprite has this weird magenta background to it. And the reason it has this is because due to the palette limitations that we imposed on ourselves, we needed a way to describe a transparent color. So our logic for drawing these characters on screen will look at the bitmap data as it's plotting the pixels on the display memory, and then it'll actually omit the transparent pixels. And that gives us that pseudo-transparency. To understand this concept further, we're going to take a look at the video game itself. We'll start with the main menu. Let's go ahead and launch Modite Adventure. So Modite Adventure launched, and we can see we're greeted with the splash screen. With the main menu launched, we can see that our character sprite is being overlaid on top of other sprites. And if you pay attention to the background, you'll see what's called parallax scrolling. In order to enable this, our logic for drawing these graphics had to know what pixels to omit when drawing these graphics on screen. If we look at the raw graphics themselves, we can see we have the trees, we have the logo, we have the moon that pops up in the background, we have the mountains, we have additional trees, the clouds, and finally the path. Now the hero sprite is actually taken from this sprite sheet. Now if we disable the logic that omits the magenta color, we're going to see the main menu look quite a bit different. Let's go ahead and do that real quick. So I'll jump to our B-bitmap class, and I'm going to jump into the draw bitmap transparent method. I'm going to scroll down. There's quite a bit of code here. The important bits I'm looking for is to check to see if the pixel is equal to the transparent color. Now we're not checking for the transparent color itself, we're actually checking for the index. And there's one more section that I want to disable. Let's go ahead and comment this if statement out, and I'll go ahead and recompile and relaunch the video game, and we'll see a massive difference. Right away, we see our splash screen render with the magenta color. And if I go ahead and move forward, we can see our character sprite rendered as well as the other sprites rendered with their magenta color. And if we are so bold to jump into the video game, we'll begin to see all the other sprites with their magenta color. So now you know that in order to enable this pseudo-transparency, our code checks for this magenta color and doesn't plot that pixel if it finds that color. Next, let's actually take a look at how the characters themselves animate on screen. Okay, so in order to understand how the animation engine works within Modite Adventure, we have to understand how the tiles are ordered. Here we have a screen called ProMotion NG. ProMotion is the tool that we use to manipulate the graphics for Modite Adventure. And what we have is essentially all of the tiles that represent our sprite ordered by index. Now I'll say right off the bat that ProMotion uses 1-base indexing, whereas for Modite Adventure we use the classic 0-base indexing. So you'll see me use a number that's 1 less than what we see. We have quite a few animations here on the character sprite. What I want to focus on is the character walking. And we see we have index 12, 13, 14, and 15. Now this becomes very important as we look at the actual code implementation for the main menu. If we jump to C-Line and we look at what's called the G-menu playfield class, we'll see what's called a walk animation anim script. Essentially it's an array of numbers that ultimately describes a script that is interpreted by our game engine. Essentially what we do is we select what's called a slot. Think of it like a location for where we store graphics. And we place what's called a label. A label is like a marker. It's basically saying start here. At the very end we have a data value for loop. And so essentially this entire script from label to loop is interpreted and run by the game engine. And so we set an offset of 1 pixel left and 0 pixels up or down. And we apply a animation step. We're saying show the image walk right value, which essentially equates to 12. You remember what I said? We're 0-base indexed. And we apply some simple math to show the increments for the frames. So we see that we have tile number 12, tile number 13, 14, and 15. And where this is used is when we actually go to instantiate our player character. So if I go ahead and scroll down, and I see when we create this new instance of our player, we tell the player class to start the animation. And then we place it on screen by applying its initial XY values. Now when you look at the actual player animation, you'll see that the frames themselves actually change. Let's go ahead and launch it. Now when we look at the main menu, we can see that the actual character is frozen in the X and Y position. And that's because we've set the X and Y properties. However, if we look at the actual code implementation, and we look at the next instance of this mPlayer value, all we're essentially doing is executing the animate function in our animate method. And then if we scroll past it, we're actually just saying to render to what we call our viewport. Our viewport essentially is the entire screen. So let's go ahead and make some modifications and see this change. So the first thing I'll do is we'll change the walking speed. We'll change this, let's say 8 times factor, which essentially is the number of frames per second divided by 30. So it's 8 times 2. And then we're going to go ahead and let's say change the X and Y positions. So instead of being X10, we'll probably give it 30. And then Y position, I'll keep there. When we launch the game, we'll be able to see that the character actually moved in the X position. So when we see the actual game launching, we'll see that not only has he changed his X position, he's also walking quite a bit slower. And this logic actually plays out for the entire game. We have a class that looks very similar that controls our enemies, it controls our player, it controls our bosses. Next, we're going to take a look at how the actual levels are developed and take a look at some of the tile maps that we created. Modite Adventure is a large game. It's got 9 overworld levels with 37 dungeons, with each dungeon having the potential to have 9 levels inside of it. Let's take a quick look at tiled, and then we'll look at how we actually implemented it inside of Modite Adventure. The leftmost section, you'll see the implementation of the tiles that we've placed, essentially known as a tile map. If I zoom out, we can see the entire overworld level itself. On the right-hand side on the bottom is our tile set. Essentially, these are different tiles that we can use and place on what's called the map layer itself. If I zoom in, we can actually change how this thing renders. We designed our levels using 4 distinct layers that represent different data entries for each of the values that we needed to comprise a level. The first thing is the map layer. The map layer is essentially a canvas that we use to paint the different tiles from the sprites inside of the sprite map. And using that, we can organize our game. So if I wanted to perhaps extend this road, I can do that as such, and then I can take perhaps, let's see, some tiles here, another tile here, and we've effectively made changes to our video game. Now, in order to do things like walls, we decided to put in what's called the map attributes layer. Now, this one is a bit ugly. The map attributes layer contains numeric values that represents different types of walls that we have to manage collision. We can see the different types of walls here. And in this case, we coded yellow to describe a walkable area and green to describe a non-walkable area. And credit to Aaron Goldman for helping make our walls with angles, giving us the ability to have more flexible layouts. Now, aside from the map attributes layer, we needed a way to place objects onto our levels. Objects include enemies, they include things like doors, they include things like chests, they include things like breakable pots, in addition to obstacles, switches, and so forth. And if we take a look at the object layer here, we can see that our hero, let's go ahead and clear that off, we can see that our hero is placed, as well as a nice, friendly spider to the right. And so finally, we needed the ability to describe an object that has some characteristics to it. So for example, if I placed a chest here, I wanted to be able to reward the player with something when they interacted with that object. So we do that by going to the Object Attributes layer section here, and we add a value. So let's say I go ahead and add, there we go. If I add a value here, that's going to now allow me to create an environment where the hero can look to his left, and then he can slash open the crate and therefore earn a health potion. So let's go ahead and see this in action. I'm going to save the level, and I'm going to recompile the game. And we see our crate appear. If we open it up, we get our health potion, and there goes our intro to the graphics side of Modite Adventure. I'm curious to know, have you worked on a video game in the past? Please consider adding it to the comment section below. Thank you very much for your time. Please consider hitting the like button and subscribing to our channel. Thank you and have a great day.